In our last lesson, we talked about how we can make an amplitude change with our sine and cosine graph. In this one, we're going to talk about how the period change will happen, and we'll see what that looks like. So again, what I want you to do is I'd like you to hop onto Moodle, and you'll see a link that says period trig functions Desmos. And I'd like you to open that up, and you'll come here. And just like you did yesterday, what I want you to do is I want you to move around B. The first blue graph is what the regular sine graph looks like, and then sine bx. We'll make some things change and that sort of thing. So I'd start with 1, so you can see that. Okay, how it's the same. And then again, move it back and forth, see what happens as you go through it. When you're done, go ahead and unpause the video. So hopefully you figured out some things. When the graph, let's just make it nice and easy. Let's go to two. Okay, so B is 2. Notice what happened with the graph. Okay, so normal blue, I'm going to zoom out a little bit. The normal blue graph, right? We talked about this before with sine. It starts at 0, goes up, goes down, goes back up, and then right at 2 pi, it starts repeating itself again. But when we made that letter B, the number 2, look what happened. It still started at the same place. But what happened is that it went up, but you'll notice it came down a lot faster than the blue graph. And right about here, which if we zoomed in should be about pi over 2, see that? Pi over 2. And came back down, and then it didn't start repeating at 2 pi, but started repeating at pi. And if we go over here, the same thing happens. So it starts going up, down again, but again, now it's starting to repeat at 2 pi. So every pi units, you can zoom it out all the way. So if you look at it, it's 1, 2 full rotations or sine waves before that 2 pi. And then we have another one, it keeps going, but it's happening a lot faster. Now, on the other hand, if I were to make this, let's say, 0.5, look at what happened to that red graph. It stretched out a lot more. Started at 0, kept going at pi, came back down and hit at 2 pi, came back up at 4 pi. So it didn't start repeating until 4 pi. So it really stretched it out. So the closer it gets to 0, kind of the longer the period gets. The higher the number, the shorter the period gets. Now, did you actually come up with a formula for it? I think I gave you guys pretty easy ones. So if this was 0.5, okay, so B is 0.5, and the period ended up being 4 pi. Think about how you would calculate that. You would do that by doing 2 pi over B, and that B is whatever's multiplying that x value in between right there. So kind of like inside the parentheses what we talked about before, and that talks about the stretch. Now, what we're going to do in this video is we're going to talk about how you would actually graph this. Now, if I were to do this, we're going to look at it 2 different ways, again with a T-chart and just kind of by graphs. Okay. A normal cosine graph, if you remember, doesn't start at 0 like sine does, but it starts at 1. So we're going to do the increments the same way. Pi over 2, pi, 3 pi over 2. And then it starts at 1, goes to 0, goes down to -1, then 0, then back up to 1. And again, what we talked about, remember dividing that graph into 4 sections. Okay, 5 lines, 4 different sections. And what that cosine graph looks like, again, we'll make this 0.5. Starts at 1, goes back down to 0, 1, 0, 1, and then we kind of just make a curve to connect them. I'll do that the other way as well. Again, I'm just dividing into 4 sections based on the period. Okay, so there we have that cosine graph. Okay, so that's actually this one right here. What we want to know what happens though is with this y equals half x. Now, we should know that this right here, having a number at half x, actually affects the period. So you're kind of responsible to know how the different numbers affect. So this is our b right here. So if this is our b, the period for this would be 2 pi over half. Well, dividing by half is like the same as multiplying by 2, so this would become 4 pi. So what that means is that this is going to stretch a whole lot. Now, I did not leave enough room on your graph paper, so you might want to just extend this. So I'm actually going to erase this a little bit. And I'm going to extend this out. And I'll kind of eyeball it. This is probably about 3 pi, and then this is about 4 pi. And again, what we figured out is now the period is now 4 pi. So what does that mean? Okay, that means instead of making my little markers at 0, pi over 2, pi, 3 pi over 2, and 2 pi, I'm going to stretch it out. And what I always say is that I'm quartering the period. So I know that it starts at 0. That's when always the graph's going to start. And it's going to end at 4 pi. Because we know that's how long it's going to take for it to kind of recycle back over. Well, halfway point between that is at 2 pi. So now I've divided everything in half. And now I'm going to go and quarter it. So now what's happened is I've extended it, and I can see how now there's 4 different sections. And again, these 4 different sections kind of refer to those quadrants, how we're stretching them out. Cosine, nothing else changes, only how it's horizontally stretching, right? Horizontal stretch versus vertical stretch. It's still going to be at 1, but it's not going to hit 0 until pi. It's not going to hit -1 until 2 pi. It's going to come back up at 0. And then go back up at 4 pi. And again, what we're going to do is we're just going to mimic that. And I can do that the other way as well. I know every pi, that's a quarter. So I'm going to mimic that over here. And I'm just going to kind of make that flow go to the other way. So go to 0, and then I know it's going to come back down to -1. Now, what would this look like for a t-chart? So let's say I couldn't visualize that as easily as maybe I did. What's going to happen is I'm still going to, mark it off with 5 points. But notice what changed and what didn't. The y values actually didn't change, right? The heights of everything stayed the same. So the heights in this case, the y values, those actually stayed the same. What did change, though, were the x values. So now for the x values, what I'm going to do is I am going to, now we're dividing by half. So I'm going to multiply them by 2. So 0 times 2 is 0. Pi over 2 times 2 is pi. And this is 2 pi. And this comes 3 pi. So I'm just taking all the y values, multiplying by 2. And then if I went to plot this, this is 0, 1. This is pi, comma 0. This is 2 pi, comma -1. 3 pi, 0. And then 4 pi, 1. And you can see how just with those coordinate points, I got those. Okay, again, the y values didn't change, but the x values did. One thing that you're going to have to do as well is you're going to have to kind of go backwards from this. What's going to happen kind of in your next, in 17.2, what I'm going to be asking you to do is I am going to be giving you the graph. Okay, so I erase the other one. So let's just say that you were given this graph right here, okay? What you would have to do, what I would ask you to do, is to write an equation based on this graph. So again, kind of working backwards for it, what would happen is I would see, first of all, whether it's sine or cosine. And really the easiest way is to see, in the center, where is it starting? Well, in the center of the graph, it's starting at 1. That's going to tell me it's a cosine graph right away. Then I go to see how long it takes to repeat. So it starts here, it ends here. So it went from 0 to 4 pi. So if the period, so let's kind of use the equation, if the period is equal to 2 pi over b, and we know that this period is 4 pi over 2 pi over b, what would happen is I would need to solve for b. So I'd get b times 4 pi equals 2 pi, divide by 4 pi, and b equals 1/2. So if b equals 1/2, I know to put that in here. What I would also do is check to see if any amplitude changes. So the amplitude is 1. That's there. So, there was no change for the amplitude. So the equation for this graph is y equals cosine half x. So something to keep in mind as we're moving forward is, would you be able to create an equation from this?